When you think of a black hole, you probably imagine something terrifying, an inescapable region of space from which not even light can escape. But what if I told you a black hole lives in your sink? Subscribe, and let's dive in. First, we're going to simulate a black hole by making water spiral into a drain, and then we'll overlay some footage of an actual black hole to see how they compare. You know, just another Tuesday. Now, normally this would just look like a drain with some water going down it, but we're going to change that just a little bit. Watch closely. Do you see that? There's a tiny ring around the drain where the water seems to speed up. This is called an accretion disk, and it's one of the hallmarks of a black hole. As matter spirals into a black hole, it speeds up and heats up dramatically. Some of the light from this heated material gets released, allowing us to see this ring around the black hole. In our simulation, we've colored the water blue to represent this ring of light. But there are also other ways to spot black holes besides looking at their pretty lights. We can also listen to them. When the water hits the drain, it makes a low rumble. Now, this might just sound like a sink, but black holes can make sounds too. As stuff falls into a black hole, it accelerates and spaghettifies. And yes, I made that word up, but it's still technically correct. As the spaghetti gets thinner and thinner, it makes a sound similar to a bowed violin string. Scientists have detected these sounds from black holes, and it matches the theory of what falling into a black hole would sound like, so it's pretty dang close. And finally, we can observe the space-time around a black hole by watching the water spin around the drain. Space-time is distorted around black holes, and the more mass a black hole has, the more it warps space-time. This is called gravitational lensing. If there was a star behind our sinkhole, we would see multiple images of it because the space-time around the black hole would bend light from the star in different directions. So we can use this effect to weigh black holes. By measuring how much space-time is distorted, we can calculate how much a black hole weighs. So now that we've made a black hole in our sink, it's time for a little science experiment. We're going to weigh it. To do this, we need a star to weigh our black hole. Luckily, we just happen to have one nearby. Now, without the black hole, star-S light would pass straight through our simulated space-time and land directly in front of the camera. But now that we've added the black hole, its gravity bends the light from the star, creating two images instead of one. We can measure the angle between these two images and use that to calculate the mass of the black hole. Remember, we pretended that this blue stuff was light. Well, light travels at a constant speed. So if we know the distance between the images and how far the light has traveled, we can calculate the mass of the black hole. And after some quick calculations, I found that our black hole weighs approximately 34 kilograms. That's about the same weight as a black hole with a 3 solar mass. Pretty impressive. From stars to sinks, gravity always wins. But this isn't the only way to make a black hole. In fact, there's another way. If you figure out what it is, you might win a prize. Here's a riddle. I eat light and time, and nothing escapes me. What am I? Go ahead and write your answer in the comments. While you're thinking, here's a hint. It's something you might see in the sky, or maybe even in your backyard. Still can't think of it. Well, how about this? I have no voice, but you can hear me. I have no body, but you can feel me. What am I? If you answered black hole, you'd be right. Well, almost. It's actually a wormhole. But that's a topic for another video. And if you made it to the end of this one, you should definitely subscribe. Or maybe don't, because if you do, I'll pull you in and then you'll never get to leave. Haha, see you later.